Today we are starting our unit on radical functions, focusing on square root and cube root functions. Okay. The basis of what we're going to do today is review graphing, transformations, how we plot points, parent functions, how we go backwards from transformations to the equation, things like that. So we're going to start by reviewing our parent functions. So f of x equals the square root of x. I know that I would fill in my table as 0, 1, 2, 3. Go ahead and plot my points. What's the domain of our square root parent function? And what's the range? Great. How would I fill in the table of my cube root parent function? Yep. Yep. Great. Go ahead and plot that. What's the domain of our cube root parent function? Yep, all real numbers, as is our range. If you don't remember these parent functions, please find a way to remember them very quickly. All right, let's review our rules of transformations. In any radical function, whether it is a cube root or a square root, the general form of our function is f of x equals a times the square root of, this could be square root or cube root, b times x minus c plus d. And the plus d, remember, is on the outside. You might also see the c written as an h and the d written as a k. Okay, so let's review, what does that a in front of our function do? Okay, in a quadratic, yep, it helps us figure out if it opens up or down, but right now I'm just focusing on transformations. No. What transformation happens if we multiply the whole function by a number? Good, it's either a vertical stretch or a compression. When your a value is bigger than 1, it is a vertical stretch. When your a value is less than 1, it is a vertical compression. And the way that you apply the vertical stretch and compression is you multiply each y value by a. Okay? What does our b do in here? Yeah, it's a horizontal stretch or compression. And remember that inside the parentheses, or in this case under the radical, does the opposite of what we expect. So when b is bigger than 1, it is a horizontal compression. Because it's the opposite of what we expect. When b is less than 1, it's a horizontal stretch. And the way we apply that is we divide, because it's the opposite. It looks like it's multiplying, so we do the opposite operation. We divide. We divide the x values by b. So that makes sense why we get a stretch if b is less than 1. If we divide by, say, 1/2, dividing by 1/2 is the same as multiplying by 2. Okay? All right. Go ahead and kind of scratch out this part. C positive, C negative. When you see x plus c on the inside of your radical, what does that tell us to do? Yeah, a horizontal translation left c. And if we see x minus c in parentheses, what does that tell us to do? Go to the right c. And the fancy name for these are horizontal translations. Alrighty. If we add d at the end, oh, I'm out of colors. If we add d at the end, what does that tell us to do? Go up d units. If we subtract d at the end, what does that tell us to do? Down d units. And those are called vertical translations. Okay? When your negative is outside of the f of x, when it's outside of the whole function, how does that reflect the function?
Over the x-axis.
Good. And the way we remember that it's over the x-axis is that when it's outside, when the negative's outside, that means it affects the y values. And the way you affect the y values is to reflect down. All right, when the negative is inside, instead, it's going to be a reflection over the y-axis. Okay, so a nice little refresher on our rules of transformations. Let's actually apply these and practice graphing. If you'd like, you can erase where it says complete the chart, because clearly there's no chart for you to complete. Okay, first thing I always like to do is decide what our parent function is. Good. And I like to plot the parent function so I know what I'm starting off with. You could do this with a dotted line. You could do it with a different color. All right, let's list our transformations going from left to right. So what's the first thing we see?
X minus 4.
Okay, and what does that do? Right, 4. And then this minus 2? Down 2. So take each of your points from your parent function and go right 4, down 2. What's the domain of our new function? 4 to infinity. And what's the range? Questions on this stuff? All right, let's try number 4. What's our parent function on number 4? Good. Go ahead and plot your parent function. It's not that it's technically like necessary to plot your parent function, but it's really easy to kind of go onto autopilot and just kind of graph whatever you graphed previously, or just start plotting points. Like for example, when I was working through these notes, I graphed number 4 as a square root function. It's just really easy. So if you force yourself to stop at the very beginning and plot your parent function, you'll be paying closer attention when you transform it, so you're less likely to kind of make one of those little mistakes. Okay, what are our transformations? Okay, a vertical stretch by 2. What does that tell us to do? Yeah, take 2 times each y value. Okay, then what? Bless you. All right, so let's start with 0, 0. If we multiply our y value by 2, still 0, 0, and then write 2. All right, 1, 1, multiply our y value by 2. We get 2, and then write 2. 8, 2, we multiply our y value by 2, we get 8, 4. Oops, but then we go write 2. And then complete it over here on the negative side. Questions on any of those points? You take your y value for the vertical stretch, you take your y values of your parent function and multiply them by 2. And there's our new function. Domain and range? Yep, they are both all real numbers. Will the domain and range of a cube root function ever not be all real numbers? Ever? No. It's always going to be all real numbers. Okay? No transformations can change that. So is there ever a reason to miss the domain and range on a cube root function? No. Fill it in. All right, let's look at number 5. What's our parent function? Square root of x. Go ahead and plot your parent function. Okay, let's list our transformations. Going from left to right, what's our first transformation? Nope, deal with this negative first. Reflect across the x-axis. Yx. Yeah, it's on the outside, so it affects the y values. So we've got to flip it down. Okay, then that 1/3, what does that do? Okay, vertical compression. And we take our each y value and we multiply them by 1/3. What does the plus 2 do? Left 2. And the minus 4? Down 4. Okay, it's harder for me to visualize reflections as to like what I'm supposed to end up with. So when I have a reflection like this that comes at the very beginning of my list, I'm going to go ahead and just kind of plot my reflection. You absolutely don't have to do this, but it's just kind of helpful so that you know that at the end you've at least ended up with the right shape. Yeah. You reflect across the x-axis because of this negative out in the front. And a negative out in front affects your y values, which makes you reflect across x. Okay, then we're going to apply our compression and our shifts left and down. So 0, 0, will a compression affect that? Go ahead and move left and down. Okay, 1, negative 1, a vertical compression takes you to what? 1, negative 1/3. Left 2, down 4. I need 3 points to complete my graph. Instead of going to 4, negative 2 next, what might be easier to deal with? Yeah, 9, negative 3. Why? Yeah, 3 is going to be a y value of negative 3 is going to be easier to multiply by a third. If I multiply that by a third, I go up to 9, negative 1. Left 2, down 4. This is hard to draw in because it's all kind of smooshed. So just do your best. What's the domain? And what's the range? Questions on those? All right. With a partner, did you have a question?
Yeah, why would it be negative infinity?
Because the graph continues down from here. So your range always goes from your smallest number to your biggest number. So the bottom level it'll reach is negative infinity. The highest it can go is negative 4. All right. With a partner sitting next to you, I would like for you to go ahead and work on 6 and 7. It might be beneficial to plot the parent functions on the graph so you can tell what changes have been applied. Just take a couple minutes and do that, please. Talk it out with each other. All right, let's chat about these. What transformations have been applied to number 6? Left 2. All right, and how do I represent that in my equation? Plus 2 underneath the square root. So that should be your equation. Your domain is negative 2 to infinity, and your range is 0 to infinity. Or so, yeah. Questions on that one? All right, so let's talk about number 7. What transformations have been applied? Okay, how many of you thought it was reflected over the x-axis? Okay, how many of you thought it was reflected over the y-axis? Yeah. In this case, either reflection works. Because there's no horizontal translation, picture your parent function. Kind of graph your parent function. This is a sneaky one. Picture your parent function. You could reflect across y and then go down 2. Or you could reflect across x and go down 2. So either one in this case is acceptable. Is that always the case? No. No, but because there is no horizontal translation, the symmetry of the cubic function allows you to include both. So your answers could look like the opposite of the cube root of x, that quantity minus 2, or y equals the cube root of negative x, the quantity minus 2. Colin?
What would be a case where it wouldn't work? Where both reflections wouldn't work?
If there was a horizontal translation also, then it gets a little dicier, and you have to go in order from left to right, so it would depend on where that negative was as to which axis you went across. Okay? But either way, your domain is negative infinity to infinity, and so is your range. Other questions?
I have to,
Yeah.
if you like say the graph is like compressed, like vertically compressed by 2,
Mm-hmm.
how would you be able to tell if it was flipped over the x-axis or the y-axis?
I'm not sure I understand your question. Can you try again?
Like I guess if like the same graph is like in a vertical stretch of 2, could you still use either or for flipping it over the x-axis or y-axis?
Mm-hmm.
Or is there like a certain one?
Yeah, it's when there's a horizontal translation that it becomes more specific. As long as it stays centered at the y-axis, either one can work.
So what if it was one over to the right?
Then it's specific based on the points. Okay. We haven't spent a ton of time with horizontal translations this year, so we're going to practice a little bit. I want you to take a sec and look back at the front page of your notes. I gave you this general form of a radical function, okay? And notice that the b value, the horizontal stretch or compression, is outside of parentheses, okay? It's got to, if there is a translation as well as a stretch or compression, you must pull out the stretch or compression, and then the translation's what's left over. You have to rewrite it in this form first. All right, so let me show you what I'm talking about. Look at number 8. You've got y equals the square root of 2x plus 4. You have to rewrite this in the form y equals the square root of 2 times x plus 2. You have to rewrite it in that form that I gave you at the beginning of class, the general form of transformations. Because the transformation is applied first, and then the stretch or compression is applied first, and then the translation. But right now, you don't have the stretch affecting the translation. I know that's not a great answer to the why, so just go with it. You can't apply, you know how like with quadratics, we could only apply transformations if it was in vertex form? That's when we were allowed to use the rules of left, right, up, down. Think of it kind of the same way. We're only allowed to use our rules if we have it in this general transformation form, okay? All right, so this 2 is a horizontal what? Compression. And that means we take our x's and divide them by 2. Okay? What does the plus 2 do? Good, left 2. Not 4.
I just don't understand why you put it back into the equation. It should be like, I mean, you obviously know that there is a horizontal compression, but like, how can you just flip
Because this is the best I can try and explain it. Otherwise, you just got to kind of keep playing with it and see it'll start to make sense. You work from left to right. So the horizontal stretch or compression affects your x value. So it affects your shift, how much you're going to shift. It affects the translation as well. So you have to pull it out so that you can apply it first and then use the translation. Okay? All right, look at number 9. What am I going to have to pull out? -5. So I'm going to rewrite this as y equals the square root of -5 times x minus 3. Good. Okay, what does that negative do? Okay, reflect across the y-axis. What does that 5 do? It's a compression. And that means we take our x values and divide by 5. And then we go right 3. All right, look at number 10. That's not cube root. That's 3 times the square root. Okay, yeah.
I have a question.
Sure.
About the last couple. Why is it automatically subtracted if we multiply?
Because remember, anything inside the radical does the opposite. So it looks like it's multiplying. It's really dividing. And when you divide by 5, it compresses the x values. Okay. All right, so I'm going to rewrite this as y equals 3 times the square root. What do I pull out? 1/2 times x what? Minus 12. Okay, so the 3 does what? Vertical stretch. And we do what? Yeah, multiply your y values by 3. What does the 1/2 do? It's going to be a stretch. And let's see why. If you take your x values and divide them by 1/2, what's that the same as? Yeah. That's why it ends up being a stretch. And then what does the minus 12 tell us? Right, 12. All right, let's look at number 11. We want to describe how we go from this function to the second function. So let's look at what we've got. To go from a vertical stretch of 2 to a vertical stretch of 4, what did you have to apply?
Another vertical stretch of 2.
Yeah, so transformation was a vertical stretch by 2.
The left 5.
Good, because to get from -3 to +2, you had to add 5, right? But adding 5 on the inside is the same as going to the left 5. Okay, I'm going to have you and your partner try number 12, and I caution you to remember you have to rewrite the inside of this radical. Yeah, what are you going to have to do to the inside of the radical? Pull out that negative. Okay, so pull out that negative and then decide the transformations. I'm going to give you about a minute or two to work with someone next to you. This is one of those problems, guys, where it really, really helps to talk it out. So bridge the barriers and talk to each other.
Now by 1/12.
Wouldn't it just be negative x minus 2? Yes. I thought earlier you said negative x.
Okay, think about how we go from 6 to 1. Or if you do the 6, get to your I'll give you 2/3. So it's going to be Okay, can I have your attention back, please?
Moving horizontally, so you can move it over the y.
Okay, so when I rewrite this, I'm going to rewrite it as y equals 1/2 times the cube root of negative x minus 2 minus 3. All right, how do I go from 6 to 1/2? What do I have to do to the 6? Divide by 12, which is going to be a vertical compression by 12. Because 6 divided by 12 gives us the 1/2. Everyone okay with that? Okay. To go from, what does this negative do? Good. And then to go from -3 to -2. We added 1, which means we went which way? Left 1. And then from +1 to -3, down 4. What questions do you have on this one? Yeah. Well, to go from -3 to -2, what'd you do?
You add 1
You added one. And remember, it's the opposite when it's on the inside. So you go to the left one. Blake?
Why isn't it a vertical compression by 112?
That's accurate. Equivalent statements. You can say that as well.
Oh, you can't say vertical
Yeah.
compression by 112?
Yeah. There's not like a standardized way of how you write the factor, so I will understand what you're saying either way. I'm more concerned with you knew that it was the compression and it was by a factor of 12.